Hello, welcome to Math 1351 review. This is the review for exam number 1. I have selected a few problems from your review that I posted on week 4 to go over, and so we're going to go over those problems. If you have any other questions, feel free to email me, and I'm happy to answer questions about any other problems. So let's get started. Oh, wait a second. I got to share my screen. Okay. So now you should be able to see my screen now. Okay, so we are going to do, again, the review for 1351. I've selected some of the most commonly missed problems on homework so far, or on the quiz, or problems that are usually a question. So that's what I want to go over now. So starting off with number 2. Number 1, usually most people don't have any issues if I'm giving you the whole, finding what's part of the whole. But if you do have questions, feel free to email me about that. So looking at number 2, we're told that the dark green Cuisenaire rod is equal to 3/5 of the unit. So we're told that for number 2, this dark green is equal to 3/5. So that fraction 3/5, it tells me that I was given 3 parts, and then 5 parts make a whole. So the question actually asks for what's 1/2 of the unit. To be able to figure out 1/2, first I need to start to find a whole. To find a whole, I need to figure out which 3 pieces are the same length as this. So you would play around and you would finally figure out that 3 reds equals 1 dark green. So this red is worth 1/5. This red is worth 1/5. This red is worth 1/5. I'm going to go ahead and draw that here on my paper so I can kind of write a little bit more about it. So this was the dark green one. And I split it into 3 pieces because this is actually 3 pieces and it's worth 1/5, 1/5, 1/5. Okay, so 1/5 plus 1/5 plus 1/5 is 3/5. So now to find a whole, I know that 5 of these reds is going to make a whole. So this would be my whole now. Okay. You could go ahead and figure out which rod is equivalent to a whole. I believe it's an orange. Yes, if you wanted to, but you don't have to at this part because the question's not actually asking for the whole. It's specifically asking for the half of the unit. So I need to figure out which rod is equal to 1/2 of that unit. And let's see. We need to find 2 pieces that are the same length. Purple's too short. How about yellow? Yellow is, there you go, that's perfect. So a yellow is worth 1/2. So my answer for this is yellow, and my work would be this. So I would need to draw this on my paper. So I would show that 5 pieces. So this, and these are 5 red pieces, and these are all 1/5. I would shade these in to show that they're red. And then from there, I want to find a half. So I would show that 2 yellows make a whole. And I don't have a yellow, but my paper's yellow, so we'll call that yellow. So a yellow Cuisenaire rod is equal to 1/2. Okay. A lot of you did not do this problem correctly on your quiz. So I hope that this helps you understand how to do it a little bit better. The next problem we're going to go over is problem number 4. Let's go and do 3. I didn't actually circle it, but let's go and do number 3 because that's the only pattern block problem I have on there. So it says that you're told that the yellow hexagon is equal to the whole, and we're looking for 7/3. So this yellow hexagon is my whole, and I want to find what is the collection of blocks that equals to 7/3. So to do this, first I need to split it into thirds to figure out what piece we're talking about. Once I know the piece, then I can use 7 of those pieces. So I would go through my pattern blocks and figure out which pattern block splits that hexagon into 3 pieces, and it is the blue rhombus. Okay, so I know what 1/3 is now based on that. Sorry, it's not too great. There you go. Based on that, so I would draw this picture. So I would draw this picture and show my yellow hexagon of a hole, which is not perfect, but it's okay. And then split it into 3 parts. This is 1/3. This is 1/3. This is 1/3. To find 7/3, I need 7 blues. So you could write your answer literally as 7 blue. You can call it a rhombus or a parallelogram. No, I spelled that wrong. Parallelogram. There we go. Sorry, having a hard time. So I could just say 7 blues would be 7/3, or you could actually draw it. You could draw out this would be 3 of them. If I draw another one, this would be 6 of them. And then I would need to draw 1 more. And then you would probably shade all these in, and you would shade the blue, which I don't have. Oh, I do too. There's a blue right here. So I would shade all these in. It doesn't work very well, but you get the idea. And I would probably label them as 1/3, 1/3, 1/3, so on and so forth. So this is 7/3. Okay. The next problem I want to go over is number 4, C and D. So let's look at number 4C. When I was grading the homework, I don't remember major issues on this, but I just want to go over just to make sure you know how to do it. Number 4C. If I was told this box is 1 2/3. Okay. So I need to figure out how many pieces to split that into to be able to find 1. Obviously, it's going to be smaller than this box, but what I need to do is write 1 2/3 as a improper fraction so that I know how many pieces we have. So 1 2/3 as an improper fraction, you do 1 times 3 is 3 plus 2 is 5. So I get 5/3. So I was given 5 pieces here. I need to split my box into 5 pieces. So if I split my box into 5 pieces, it looks like that. Each of these pieces is called 1/3. 1/3, 1/3. And when I add them all together, this should equal 5/3. 1 plus 1 plus 1 plus 1 plus 1 equals 5/3 right there. So to find 1 whole, I would use 3/3 because 3 parts make a whole. Okay, so this, you could do it 2 ways. You could draw it like that if you wanted to and show 1/3 on each of them. Oh, that got kind of messy. Or you could literally draw your original piece, split it into 5 parts, and shade in 3 of those parts and say that equals 1 whole. Either one of those is acceptable as long as for this, you show your 3 pieces and you label them 1/3. If you just didn't do anything and didn't even, if this was the problem, this was 1 2/3 and you said, it looks to be about that. That would be wrong. You have to show some kind of work to explain your reasoning. Okay, for 4D, we're told that this equals 3/4. So this time I'm given, and I'm looking for a whole. So this time I'm given that this is 3 pieces. The name of each piece is 1/4, 1/4, 1/4. If I add them together, 1/4 plus 1/4 plus 1/4 equals 3/4. So to find a whole, I use my bottom number. 4 parts make a whole. So I can do this a couple different ways. One way is if you show all this information, you could draw 1 box that has 4 parts, as long as like this is the same size and you added almost the same size at the end, and you label each one of them 1/4, 1/4, 1/4, 1/4, and that equals 1 whole. That is an acceptable answer. Or if you wanted to draw this specific box again, so I draw 2 of them, they each have 3 pieces in it. I'm going to shade in 4 of those boxes. So either of those is an acceptable answer. Okay, the next problem I want to go over is number 5D. So if you look at number 5D, we're told that those dots, 1, 2, 3, 4, 5, 6, 7. There's 7 dots here. 4, 5, 6, 7. Not 7 dots, there's 14 dots. 8, 9, 11, 12, 13, 14, 8, 10, 12, 14. We're told that this set of dots of 14 dots is 1 3/4. And we're trying to find one whole. So to find one whole, I need to split that 1 3/4 into the number of parts that it was given. To figure out how to do that, I need to make this an improper fraction. So I'm going to do 1 times 4 is 4. 4 plus 3 is 7. So 7/4. So I was given 7 parts. I need to split this set into 7 parts, and I can do that like so. The name of each part is 1/4. This is 1/4. This is 1/4. So on and so forth. Okay, so then they want us to find, what is it? One whole, draw one. So 4/4 is a whole. This would be my hole right here. So I would draw that. 4/4, 1, 2, 3, 4. Each set has 2 dots in it. 1/4 plus 1/4 plus 1/4 plus 1/4 equals 1 whole, and this is a total of 8 dots. So you can draw it or you can write 8 dots. Okay. The next one I want to go over is number 6. Instead of drawing all these dots, I'm just going to do it on this paper. Okay, so it says the group of the dots. Now I'm going to go and draw it. Let's see. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 24. So 1, 2, 3, 4, 6, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4. Okay, so it tells us that this set of dots is 4/3 of the unit. We want to find 5/9 of the unit. To be able to do that, first I need to figure out how many parts I was given and figure out the whole. Okay, so I was given 4 parts here because that's the top number, so I need to split the set into 4 groups. To do that, 24 dots divided by 4 groups means 6 need to be in each set. So 1, 2, 3, 4, 5, 6. This is the first set. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay, the name of each of these sets is 1/3, 1/3, 1/3, 1/3. 1/3 plus 1/3 plus 1/3 plus 1/3 is 4/3. So now, to be able to find 5/9, first I need to find the whole or the unit. So 3 parts make a whole. So this is my whole. So this equals 1 whole. So I'm going to redraw that. 1, 2, 3, 4, 5, 6 is the first set. 7, 8, 9, 10, 11, 12 is the second set. 13, 14, 15, 16, 17, 18. So this is my whole. Now I need to find 5/9. To find 5/9, first I need to take my whole and split it into 9 parts. So I have 18 dots here. To split it into 9 parts, I'm going to put 2 dots in each group. Okay, the name of each of these groups is 1/9, 1/9, 1/9, so on and so forth. Okay, so 5/9 would be 5 of these groups. 1, 2, 3, 4, 5. So this is 5/9. So you can redraw those 5 groups with 2 dots each, or at this point you could just say, okay, I know that 10 dots is my answer. Okay, so I hope that that helps. And I hope that you're seeing with all these problems, you have to know the whole. Everything is related back to the whole. You cannot solve this problem without finding the whole first. This problem, you were given the whole, and then you have to break it down from there. For this problem, we were looking for the whole. We're looking for the whole there. Here, we're looking for the whole, but here you were given a part and asked for a part, and we had to get to the whole first to be able to do any of that. So with fractions, finding the whole is super duper important. Okay, the next problem that I want to go over was number 10. Use 3/4 divided by 5/7 as an example to explain why the following technique for division of fractions works. multiply the first fraction by the reciprocal of the second fraction. Okay, so I don't actually care about the answer here. I don't care about showing how to invert and multiply. The question is, why does this work? Okay, so let's go over that. For number 10, so we're using this example, 3/4 divided by 5/7. The question is, why can I change this to 3/4 times 7/5? Okay, not what's the answer, not show me your work. Why is this problem the same as this problem? Why can't I just change division into multiplication? If that was the case, I would take my paycheck and instead of dividing it among like 2 bank accounts, I would multiply by 2 or whatever. Okay, so why is it allowed in this specific problem? Okay, so there's a couple of different ways you can do it. There's a couple of different ways you can explain it. I believe in the video I showed earlier, we wrote this as a fraction within a fraction. So we wrote this as 3/4 divided by 5/7. Okay, and that is a mess to have a fraction and a fraction. So if we can get this number off the bottom, that would be helpful. The way we can get this number off the bottom is to turn it into 1. The way that I can turn this into 1 is by multiplying by 7/5, because what happens then is 5 times 7 is 35, 7 times 5 is 35, and 35 divided by 35 is 1, which is, now I don't need to write it as the denominator anymore. Okay, so I'm not allowed to just multiply some random part of a problem by some random number. So the way that I keep this even is I have to also multiply the top by 7/5, because this is equivalent to 7/5 over 7/5. This is the equivalent to multiplying by 1, which is allowed. I'm allowed to multiply by 1 anytime I want to. Okay, so then you probably notice that on top I have 3/4 times 7/5. I don't actually care about the answer here, so I'm not actually going to multiply it out, but notice we started with this and we ended up with the multiplication problem. Okay, so I hope that is helpful with explaining that one. The next one I want to go over is number 11. Actually do this problem, but do not multiply by the reciprocal. Okay, so I'm actually going to do that problem this time, 3/4 divided by 5/7, but instead of multiplying by the reciprocal, here we're going to use common denominators. Okay, so the common denominator here for 4 and 7 would be 28. So I need to take 3/4 and I need to multiply it by 7/7. And I get 21/28. I'm going to do the same thing with 5/7. I want to turn it into a number over 28, so I'm going to multiply by 4 on bottom and on top. And so I get 20/28. So this problem now with my common denominators becomes 21/28 divided by 20/28. When I divide across the top, 21 divided by 20, that doesn't divide evenly, but I can write it as like 21/20. On bottom, 28 divided by 28 is 1, so I don't need that denominator anymore. So my answer is 21/20. The next problem I want to go over is number 13. I wanted to do the word problems here. You can do these problems any way you want to. You can make a simpler problem out of it, work it out, and then use the bigger problem. You can draw a picture. You can do whatever you want. I just need some kind of work showing that you know how to do this problem. Okay, so number 13, Mrs. Jones baked a batch of cookies for a Christmas in July party. Her children promptly ate 1/3 of the cookies while they were still warm. Then her husband came home and ate 2/5 of the remaining cookies. What fraction of the batch of cookies was left for the party? Okay, so for me, this problem is easiest when I draw a picture for it. So here is Mrs. Jones' batch of cookies. Okay, so it says her kids ate 1/3 of it. So she made it, her kids came home and ate 1/3 of those cookies, which I'm really hungry right now, so that sounds delicious, some warm cookies. Okay, so these are gone, the children ate those. Then it says that her husband came home and ate 2/5 of the remaining cookies. So of this part right here, we want to find 2/5 of that. So I need to split all of this into something that can divide by 5. So I'm going to split it into 5 pieces this way. 1, 2, 3, 4, 5. There we go. Okay, so her kid still ate 1/3 of it because 1, 2, 3, 4, 5 out of 5, 10, 15, 5/15 is the same thing as 1/3. So I didn't change anything so far. I just broke it into more pieces here. So now her husband came home and ate 2/5 of what is left. So if I count what's left, the number of pieces left, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He ate 2/5 of them. So I need to shade 2/5 of them. 2/5 of 10 would be 4. You can also think about it as like, see it as like this is 1/5, 2/5, 3/5, 4/5, 5/5. He ate 2 of them. So this is what her husband came at, ate. Okay, so then the question asks, what fraction of the batch of cookies was left for the party? So I have 1, 2, 3, 4, 5, 6 pieces left out of how many did we start off with? 1, 2, 3, 4, 5, 6. Count them up and you have 15. So 6/15 is one answer. You can also reduce that answer and they both divide by 3. And so I get 2/5. 6 divided by 3 is 2. 15 divided by 3 is 5. So 2/5 is left over. Both of these answers is fine. And if you're like having a moment but saying, but this was 2/5, so why is this 2/5? It's because we're comparing to 2 different wholes here. Her husband ate 2/5 of the remaining cookies. So this black part is 2/5 of that. This is 2/5 of the whole that's left over. I hope that explains that a little bit better. Okay, the next problem is number 14. Mr. Jones is preparing the family swimming pool for the party. The directions on the chemical bag says put 3/4 a cup of the chemical spraying system for every cubic yard of water in the pool. He estimates that the pool holds 16 2/3 cubic yards of water. How many cups of the pool chemical should he add to the filtering system? Okay, so you can do this a couple of different ways. You could draw a picture. I think at the end it's going to get a little hairy if you draw a picture though. For me, just making this into a simpler problem is easier, or is the easiest way for me to do it. So if I was looking at this, it would say the directions on the bag say, I'm going to make this an easier number. Put 1 cup for every cubic yard. And then if I say my pool holds, let's take off the fraction, 16 cups, how many cups would you do? Well, 1 for each of that would be 1 times 16 would be 16 cups. So I need to multiply these two numbers. For every cubic yard, I put in 3/4 of a cup. So I'm gonna do 16 times 3/4, and then I'm gonna do 2/3 times 3/4 to figure out that little extra part. Okay, so to do this problem, you would do 3/4 times 16 2/3. So you can do this however you want to. I am going to make it an improper fraction first. So 3/4 times 16 times 3 is, I think it's 48. Let me double check my math real fast. 16 times 3 is, yes, 48. And then 48 plus 2 is 50/3. From here, you can multiply across the top, multiply across the bottom, or you could reduce first. It's up to you. I'm just going to go multiply. 3 times 50 is 150. 4 times 3 is 12. And I can reduce that to, they both divide by 6. So 150 divided by 6 is 25. 12 divided by 6 is 2. So 25/2, that's a totally acceptable answer, but for this situation, it's kind of confusing because you say 25 halves cups. That seems kind of weird. So let's make it an improper fraction. 2 goes into 25 12 times with 1 left over. Yeah. So 12.5 cups is how many he needs. Okay. Look at the next problem is number 16 that we're going to go over. Is this fraction 6 over 1125, 1125, is it equivalent to a terminating or non-terminating decimal? Okay, so the answer is yes or no, and then explain how you get it. So the first thing I need to do for all of these problems is reduce it. Can this fraction reduce? If it can, you have to reduce it first before you decide if it's terminating or non-terminating. This fraction does not reduce. So let me, yeah, because it's E, well, does it divide by 3? Let's see, 7, 8, 9. Oh, it does divide by 3. I was about to get that wrong. So on the fraction, look, 1125 divides by 3. So I need to divide them both by 3. So 6 divided by 3 is 2. 1125 divided by 3 is 375. So that's the fraction I'm working with. To decide if it's terminating or non-terminating, remember, you have to break it down into the prime factorization. If the denominator only has 2's and 5's, then it is a terminating decimal. Any other factor other than 2's and 5's is a non-terminating. Okay, so let's take this number 375 and let's break it down. So 375 is 5 times 75. Let me move my paper up a little bit. 5 is a prime number. 75 breaks down into 3 times 25. And 3 is a prime number. 25 breaks down into 5 times 5. So 375 is equal to 3 times 5 times 5 times 5. Does this only have 2's and 5's in the denominator? No. If it only had 2's and 5's, it would be terminating. Since it doesn't, it is a non-terminating decimal. Okay, and you can double check yourself and divide it to your original problem. 6 divided by 1125, and you can see it is a non-terminating decimal. It's a repeating decimal. You have to show all this work though. You can't just put it in your calculator and say it's non-terminating. Okay, and the last problem I'm going to go over is number 18, converting that decimal to a mixed number. Okay, so this is one of the harder ones. It probably won't be this hard on your test, but if you can do the hard one on the review, it should be a breeze to do it on your test. So 53 and 209, the 09 is the repeating part, not the 2. So this is the one that you have to make a few different equations for. The first thing you do is let x equal 53.2090909. Okay, remember I need to get one repeater in front of the decimal place, so I want to move my decimal to here, so I want to move it over 1, 2, 3 times. So I need to multiply by 1,000 to move it over that many times. So 1,000 times x would be 1,000x. When I multiply the 53.2090909 by 1,000, I get 53,209.090909, so on and so forth. So now normally we would put this underneath it and subtract it off. The problem is if I put x underneath this and subtract it off, that 2 is going to make this be off because 2 and 0 don't cancel out, 0 and 9 don't cancel out, so on and so forth. So remember I have to multiply this one by 10 now. I want to move the decimal place to here this time so that it's just 090909 at the end, so it'll match up. So that's just multiplying by 10 this time. So 10 times x is 10x. When I multiply this by 10, I get 532.090909. And so now 1,000 minus 10 is 990. 53,209 minus 532 is 52,677. And all of my decimals cancel out here, they subtract off. So now I divide by 990. And so I get x equals, I need this as a mixed number. So first thing we want to do is reduce it. And if you don't have a calculator that you can just do math enter. I don't have that calculator with me. Let's kind of go through. Let's see. I know the bottom divides by 9, right? 990 divided by 9. So 110. So let's see if the top divides by 9. It does. So let me start off by dividing them both by 9. I get 5,853 divided over 110. Let's see if the top number divides by 11. No, I'm thinking that is the simplest form because it doesn't divide by any even number. The top doesn't, and the bottom only divides by 2, 5, and 11. So I think that's the simplest form there. So now to make it into a mixed number, how many times does 110 go into 5,853? Well, it goes in 53 times. What's the number of pieces I just used by making 53 holes? Well, 53 holes times 110 pieces each. I used 5,830 pieces. So the pieces that are left over would be 23 pieces left. So 23 over 110. And you can check and make sure that decimal, it's 2090909 like it was supposed to be. Okay. So that is my answer for that one. Okay, so that is all the problems that I had planned on going over. If you have any questions, please feel free to contact me, or, sorry, I'm trying to email me, or whatever you need to do, and I'm happy to meet with you. I can meet with you in person, or we can do a Zoom meeting.